This video is going to walk us through limiting reactants. So just to remind you, we always want to go from moles of what we have to moles of what we want using our balanced equation or our ratio. Okay, if we don't have moles and we're given grams, then we know we can get to moles using the periodic table. And we know that if we need to end in grams, we know we can get there using the periodic table, right? Because our molar mass always tells us our number of moles, our number of grams per 1 mole. So when we're working a limiting reactant, we do the exact same calculations as we have been doing, but you just have to do them twice, right? Because we want to know how much each of those can produce, because I know that my limiting reactant is going to be the one that limits how much I can make because it's run out first, right? So I'm always going to start with what I'm given. So I'm given 1.85 moles of sodium hydroxide, and I'm given exactly 1 mole of carbon dioxide. Okay, so I'm starting essentially here and here, and then the next question, when it's asking me for my theoretical yield, it tells me that I'm looking for this. So I'm going to go ahead and make sure I'm solving for sodium carbonate so that I already know my answer. Okay, so to get started, right, I'm at moles. I'm trying to get to moles, right? Moles of what I have, moles of what I want. So I'm going to use that balanced equation. So my equation tells me that I have 2 moles of NaOH for every 1 mole of sodium carbonate. So now I can just multiply the top, divide by the bottom, and I end up with 0.925 moles, okay, of sodium carbonate that can be produced. So now I'm going to do the same thing with CO2. Okay, so I'm looking at CO2 is on the top, so I know CO2 has to go on the bottom. There's an invisible 1 in my equation. So this is a 1-to-1 ratio. So when I multiply the top, divide by the bottom, I end up with exactly 1. Okay, so remember the limiting reactant, this produced the smallest amount. So my limiting reactant is NaOH, sodium hydroxide, because I ran out before I could get to 1 gram. So I know that that's my limiting. The next question just asks me how many moles can be produced. So this is what we call that theoretical yield, right? Theoretically, how much should I be able to make? And that is what we already solved for, right? So we said that we originally solved to see how much sodium carbonate we could make, Na2CO3, and we figured out that we can only make 0.925 moles because we ran out of NaOH, right, before we could get to 1. So our theoretical yield, how much can we make, is what you already figured out. So if you do this calculation, right, for our limiting reactant, you're essentially answering 2 questions in one. You're figuring out which one is limiting, and you're also determining that theoretical yield. Okay? So let's look at the next one. So again, we're going to start with what we're given, right? 30 grams of C6H6 and 65 grams of bromine. So we're starting here and here, okay? And remember, we're looking for, it asks us the theoretical yield of C6H5Br. And again, this equation's already balanced, so we don't have to do any balancing. But since we're starting with grams, remember my first step has to be getting from grams to moles. So I'm going to use that periodic table, add up my molar mass, So now I'm in moles. Now I can go from what I have to what I want. So my equation tells me I have a 1-to-1 ratio. So I'm using that ratio to convert to what I want. Okay. And remember when we said typically our theoretical yield is in grams, right? Because when we're comparing it to the actual yield that's in grams, they have to be the same units. So if it ever asks you for theoretical yield and that's all it says, you know you're looking for grams. So that means my last step is going to be to use that periodic table to convert from moles to grams. So when I add up my masses, I get 157.01. So now I'm ready to multiply the top, divide by the bottom, and I get 60.3 grams. So now I just have to do the same thing with bromine. Okay, again, I'm in grams, so I have to use that periodic table to convert to moles. So when I add up two bromines, I get 159.81. Now that I'm in moles, now I can go from here to here. I can use my ratio, which is a 1-to-1 again. To convert to what I want. And then again, my last step, because I'm looking for that theoretical yield in grams, I'm going to use my periodic table to convert to grams. And then when I multiply the top, divide by the bottom, I get 63.9. So this is my smallest amount. So that means this guy is my limiting reactant, right? Because I ran out of him before I could get to 63.9. He can only make 60 grams, which is the smallest amount, which means he ran out first. So my theoretical yield is 60.3 grams of that C6H5Br, okay? So for B, when it's asking for percent yield, remember percent yield, I remember it like AT, actual over theoretical. So it tells me my actual yield was 56.7. Okay, and then remember we just calculated our theoretical yield here. So that would be 60.3 grams. And when I divide that, I get 0.94 something, I think 1 maybe. 940. And remember, because we want a percent, we have to multiply by 100 because that's how everything, a percent is always based out of 100. So we end up with about 94%, which is pretty good. So when we're doing our limiting reactant, remember the math part is the same. You're still setting up your calculations just like regular stoichiometry, right? Moles of what you have to moles of what you want using that balanced equation. Then you're just looking to see which one you ran out of first. That's your limiting. And then you can determine your theoretical yield because that is your answer for your limiting reactant.